I'm Bella. Welcome back to my YouTube channel. In this video, I will share with you Form 4 Math Chapter 1 Quadratic Function and Equation. Let's start! The exercise syllabus Form 4 Chapter 1 Quadratic Expression and Function. Before we start, let me introduce you what is quadratic expression look like. Okay, it looks like ax squared plus bx plus c with the condition a cannot be 0. There are few conditions to fulfill. It is a quadratic expression. Of course, this is the first one. Okay, this is the first characteristic, which is a cannot be equals to 0. What about the second characteristic? The highest power is equals to 2. Okay, and then we go to the third characteristic. It is only got one variable, which is variable x. It cannot be axis got a variable y or variable z or variable a. It only can have one variable. Okay, let us see the example 1. Determine whether each of the following expression is a quadratic expression in one variable. If not, justify your answer. Part A, 2x squared plus y. Is this a quadratic expression in one variable? No, it's not. Why? Because it got two variables, which is x and y. So this is not a quadratic expression in one variable. Let us proceed to B. G plus 1 times G plus 1. We have to expand it. Become G squared plus 2G plus 1. Is this a quadratic expression with one variable? Yes, it is one variable. Is the highest power is equals to 2? Yes, it is. The highest power is equals to 2. How about the A? The A is equals to 1. So it is not equals to 0. So this is a quadratic expression in one variable. We go to the part C. 2x squared plus 2x plus 3 over x. Let us make the equation become like this. Over x plus 2x over x plus 3. Then it will be look like 2x plus 2 plus 3 over x. Can you tell me, is it a quadratic expression in one variable? No. Why? The power of one variable is not a whole number. Okay, so we go to the part D. A squared plus 2a over a plus 1. Of course, we know that this is not a quadratic expression. We go to the part E. You see, 9c squared only got one variable. The highest power is 2. And then the a is equals to 9, not equals to 0. Yes, this is a quadratic expression in one variable. But how about the bx plus c? Doesn't have. Never mind. As long as it fulfills 3 characteristics, which is a not equals to 0, the highest power is 2, and only one variable. Okay, then it is a quadratic expression with one variable. Let us go to the last example. Y squared plus 1 over 3. It will be rewrite it become plus 1 over 3. The highest power is 2, one variable, and a is not equals to 0. So this is a quadratic expression with one variable. Next, let us see the type of the relationship of the quadratic expression. Okay, so there are 4 types of relationship, which is one-to-one, one-to-many, many-to-one, and many-to-many. Okay, one-to-one, it will be look like this. Okay, one object only got one image, and one-to-many, that means one object got many image. The graph will be look like this. For many-to-one means got 2 objects share with one image, and many-to-many will be look like this. Okay, this is the relationship of many-to-many. For quadratic function, it is many-to-one. Okay, maybe the question will ask you in this way. It will draw 4 graphs, A, B, C, D. Okay, let me write A, B, C, D. And it will ask you, which one fulfill the quadratic expression with one variable? Which graph? Then you will know it is a graph B. Is the one which fulfill the quadratic function. Okay, and then another way it will ask you A, B, C, D. Which type of relationship belong to quadratic function? One-to-one, Many to one, one to many, or many to many? It is many to one. Okay? Now we proceed to the shape of the graph. For the quadratic function graph, we only got two types of graph. One is smiling graph, one is a sad face graph. Okay? When the a is greater than 0, it will be a smiling graph. When a is smaller than 0, it will be a sad face graph. Okay? So for the a greater than 0, we call it a minimum graph. Okay? Minimum graph. And this we call it a maximum graph. Okay, for a minimum graph, we have a minimum point, and for maximum graph, we have a maximum point. Now let me introduce you what is the axis of symmetry. It is a line that divides the graph into two parts which is same size and same shape, and the axis of symmetry will pass through the minimum point and maximum point. Okay, now we go and see what is the effect of changing the value of coefficient a, b, and c of the quadratic function. Okay, let's say my value of a is greater than 0. That means 5. Okay, and then I change my 5 to 2. Okay, I decrease my a. Okay, what do you think my graph will be look like? Okay, my graph will become like this. It will become when my a is decreased, my graph will become wider. So in another way, when my a increase, let's say from 2 to 5, in another way, my graph will become narrower. Okay? If my a is smaller than 0, my a is -5 and it changed to -2. Okay? So it's increased from -5 to -2 is increased. My a is increased. My graph will become wider. So my graph will be look like this. Okay, if my a change in another way, that means decrease from -2 to -5, which means the red color become the blue color, it will become narrower. Okay, so depends on whether your a is greater than 0 or smaller than 0. Then depends on whether your a is decreased or increased, then your graph will become wider or narrower. Then what conclusion can we make? We can make the conclusion that a determines the shape of the graph. Okay, now we go to see what is the effect of changing the value of b. For the a is greater than 0, the b increase. The b increase from b equals to 1 to b equals to 4. That means b is increasing. For this, a is also greater than 1. But when b is equals to 1, change to b is equals to -4. So the b is decreasing. When the b is increasing, the graph will move from the original position to here. Okay? When b is decreasing, the original position of the graph will move to the right-hand side. Why? I can show you the reason. Okay? So let us factorize this. X squared plus 4x, it will become x times x plus 4. Okay? And then x is equals to 0. X is equals to -4. So these two are the roots. So here is the 0 and here is the -4. That's why the graph will move to the left-hand side. Let us factorize this. Okay, so the x squared minus 4x is equals to 0. X minus 4 is equals to 0. X is equals to 0. X is equals to 4. So the whole graph, the roots will be 0 and 4 at here. So the whole graph will move to the right-hand side. Okay, let's proceed with the a smaller than 0. Okay, so here the b is 0, the b here is 4. So the value of b is increasing. The b at here is equals to 0, the b at here is equals to -4. The value of b at here is decreasing. So can you guess what happened to the graph? The b will move to the right-hand side. And at here, the b will move to the left hand side. So what conclusion we can make from here? The value of B determine the position of axis of symmetry. Okay, it will change the axis of symmetry to the left. It will also change the original axis of symmetry to the right. So it will change the position of the axis of symmetry. For the last part, let us see what is the effect of changing the value of C. For this part, it doesn't matter whether the A is greater than 0 or A is smaller than 0. As long as the C is increased, the original C is equal to 0 and now the C is 2. So the C is increased. When the C increases, the whole graph will be moving up. Okay, the whole graph will moving up. If the C decrease, no matter the A is positive or negative, okay, so the C at here is equal to 0, the C at here is negative 2, so it is decreasing. When C is decreasing, the whole graph will be moving down. Okay, we're moving down. So as a conclusion, the changing value of C will move the whole graph up or move the graph down. Okay, so for example 2, the diagrams show the graph of two quadratic functions. What are the possible value of A and C? Okay, let us determine what is the original A. The original A is equal to negative 2. The original C is 2. And the new A and C is at here. The first thing, I will look at the C first. Okay, you see the C here is 2. And the new C will be smaller than 2. So I will see which one is smaller than 2. Of course, this is not the answer. And I know this is not the answer too. Why? Because here is not the 0. It's in between of 2. Okay? Okay. And I also know C is not equals to 2. Why? Because here is already 2 and it must be moving down. So the only answer is this. So my answer is A. So normally I will look at the value of C first before looking at A and B. Okay? This is the easier way. Let us go to the example 3. The diagram shows the graph of quadratic function f(x) equals to ax squared plus bx plus c. Calculate the value of each of the following. Okay, for the first thing, we have to calculate the value of c. From the graph here, we got 3 coordinates, which is this, 0, 6. And this one is negative 1, 0. And this one is negative 3, 0. To calculate the value of c, which coordinate we should use? We have to look back our quadratic equation, okay? You see, we have to calculate the c. And here still got an unknown a. So I know that I must make my a disappear. I will use the coordinate 0, 6. Why? Because my x here is 0. When I substitute 0 into here, my a will become 0. So I will choose this coordinate. Okay, let me show you. f(x) is equals to ax squared plus bx plus c. And I choose this coordinate. f(x) is equals to 6. My x is equals to 0. Square plus x 0 plus c. So my c is equals to 6. So my answer is 6. Okay. For part B, I have to calculate my m. You see, this is the axis of symmetry which passes through the minimum point. And the distance here is divided into 2. The distance between negative 1 and negative 3 is 2 units. So I know that here is negative 2. And I know my m is equals to negative 2. Okay. Now we proceed to find the value of a. To find the value of a, I must use this or use this value. I cannot use this. Why? If I continue to use this, I cannot find my a because my x is equal to 0 when I substitute inside. Okay, so I will use this or either this. So let me choose this. Okay, f(x) is equals to ax squared plus bx and the c is equals to 6 plus 6. Let me choose the negative 1 and 0. So here is the 0. A negative 1 squared plus a negative 1 plus 6. Then I will get my a is equals to 2. Okay, so I can finalize my equation as 2x squared plus 8x plus 6. And finally, I have to find my value of n. My value of n, I can use the value of m to find because fx is equals to 2x squared plus 8x plus 6. My value of x here is negative 2. So this is n 2 negative 2 squared plus 8 negative 2 plus 6. So my n is equals to negative 2. This is the way how you solve the question, okay? Now we proceed to example 4. The diagram shows part of the graph of quadratic function fx equals to negative x squared plus 6x minus 5. The straight line AB is parallel to the x-axis, okay? Determine the coordinate of A. We have to determine the coordinate of A. Before I determine, I know that my value of x is equals to 0, and this is my y value that I have to determine. So from the quadratic function here, fx is equals to minus x squared plus 6x minus 5. Now I will substitute my x equals to 0 into the quadratic function. So negative 0 squared plus 6 times 0 minus 5. So my fx is negative 5 when x is equals to 0. So my coordinate of point A is equals to 0, negative 5. Okay? The equation of the axis of symmetry. So I have to find the two roots at here. Okay? So negative x squared plus 6x minus 5 is equals to 0. I have to factorize it. Okay? So it's equals to negative x plus 1, x minus 5. So my x will be 1 and x is equals to 5. So I know here is 1, here is 5. And the axis of symmetry will divide the graph into same size and same shape. So this will be the axis of symmetry. So the distance between 1 and 5 is 4 units. So I know that here is 2 and here is 2 units. So here will be 3. 1 plus 2 is equal to 3. So my axis of symmetry is x equal to 3. The coordinates of point B. Here my y is negative 5. So what is the coordinate of x when my y is negative 5? So I will substitute into here. Negative 5 equals to negative x squared plus 6x negative 5. Okay, I will move this to the left hand side. X squared minus 6x minus 5 and plus 5 is equals to 0. Okay, so I will get equals to 0, factorize it. X is equals to 0, x is equals to 6. When my y is negative 5, my x is equals to 0 and 6. Now here is a 0 and another point is 6. Okay, so my coordinate of point B will be 6, negative 5. Okay, the coordinates of the maximum point P. Okay, it wants us to find the point P. Since I already know this is 3, so my x value is 3. Now I have to find my y value. Okay, so my y value is equals to when I substitute the 3 inside. Okay, plus 2, 3, minus 5. Then I will get my answer is 4. So my coordinate P, okay, maximum point P will be 3, 4. That's all. Okay. Let us proceed to the example 5. Form a quadratic equation based on each of the given information. We have our task is form a quadratic equation. I didn't ask you to solve. I just asked you to form. Okay, form a quadratic equation. The sum of two numbers, x and y, is 16. So you will add the x and y is equals sum. Okay, add it up. Okay, the sum of the square of this number, the square of this number is x squared plus y squared is equals to 130. So I got two equations from this equation. Now I have to substitute my equation 1 into equation 2. Before I substitute the equation 1 into equation 2, I have to change this equation 1 become x equals to 16 minus y. Okay, So I will substitute my 16 minus y squared plus y squared equals to 130. Then I will expand the 16 minus y. Okay, I will get 256 minus 32y plus y squared equals to 130. Then I will rearrange it become a quadratic expression, which is ax squared plus bx plus c. Okay, so it's 2y squared minus 16y plus 63 is equals to 0. Now we proceed to the part B. The length of the rectangle exceeds its width by 3 cm given the area of the rectangle is 130. Okay, so let me draw the rectangle out. The length of the rectangle exceeds the width by 3 cm. So let me assume the width is x and the length is x plus 3 because it says the length exceeds the width by 3 cm. And the question gives me that the area is 130. So how we calculate the area? X times x plus 3 is equals to 130. So I will get x squared plus 3x is equals to 130. X squared plus 3x minus 130 is equals to 0. That's all. The equation you get. Okay? Part C, Sean bought a number of pens for 20 ringgit. If each pen has discount 20 cents, he could have bought 5 more pens for the same amount of money. Now we have to form a quadratic function for this condition, okay? So how much does Sean have? 20 ringgit. Okay, let's say, okay, x is equals to number of pens. Okay, if I want to calculate the price of one pen, how can you calculate? You have to use the money and divide the total number of the pen that you have. Then you will get the price of one pen, right? Okay, so Rm 20 over x, you will get the price for one pen, right? The price for one pen. And the question says if you get a discount of 20 cents for each pen, you could have bought 5 more pens with the same amount of money. Okay, with the same amount of money, still 20 ringgit, didn't change, but you can get 5 more pens. Original is x, and you can get 5 more pens. This is number of pens, okay, that you get after discount. Okay, so the original price of one pen is Rm 20 over x, and the price after discount is Rm 20 over x plus 5. So the difference is how much? Rm 20 cents. Okay, the difference, the original price, let's say the original price is 1 ringgit per pen. Okay, one pen is 1 ringgit. And after discount is 80 cents. So the difference is 20 cents. Okay, so now you have to transform this to become a quadratic expression. Okay, I will do like this. Rm20, I will make the denominator become the same. Okay, x plus 5 minus 20x. And then x plus 5 is equals to 0.2. 20x plus 5 minus 20x is equals, I will time this out, 0.20x plus 5. Then I will continue to expand this equation. 20x plus 100 minus 20x is equals to 0.2 x squared plus x. Okay, now I will rearrange it become x squared plus bx plus c. I will get 0.2 x squared plus x minus 100 is equals to 0. Then I will times the whole equation with 5. And I will get 5x minus 500 is equals to 0. Now we proceed to the roots of the quadratic equation, okay? For example 6, mark the roots of each of the graph of the quadratic function. So when you see the graph, which one is the roots? Here and here, okay? And here got 1 roots. Is it possible they'll have no roots? Yes, it is possible, okay? they'll have the possibility that no roots. This is the graph with no roots. This is 2 roots and this is 1 root. What is the meaning of the root? Okay, let me show you. When x is equals to -1, when you substitute the x equals to -1 to the quadratic function, the whole quadratic function will become 0. F(x) is equals to -1 square minus -1 minus 2, and you will get your 0. Let's try the 2. X is equal to 2. F(x) equals to 2 square minus 2 minus 2, and you will also get 0. So this is the meaning of roots. When you substitute this into the equation, you will get 0. Then this is the 2 roots, okay? Example 7. Determine the roots of the following quadratic equation by factorization method. No matter how the equation look like, you only have one direction. You have to change it to become ax squared plus bx plus c is equals to 0. Okay? For here, I will expand it. Become 3m squared is equals to 2m minus 6 plus 11. 3m squared minus 2m plus 6 minus 11 is equals to 0. 3m squared minus 2m minus 5 is equals to 0. Just then you factorize it. Okay? It will become 3m minus 5m plus 1. I will get my m is equals to 5 over 3. M is equals to -1. Okay? For part B, I will do cross multiplication. Okay? 2x squared minus 3x is equals to 2 times x plus 6. Then I will get 2x squared minus 3x is equals to 2x plus 12. 2x squared minus 3x. I will move the 2x to the left hand side. Minus 2x minus 12 is equals to 0. 2x squared minus 5x minus 12 is equals to 0. Does it look like the quadratic expression? Yes, just then you factorize it. Then you will get your answer 2x plus 3x minus 4. Your x is equals to -3 over 2. X is equals to 4. Okay? For the last, I will also do the cross multiplication. -3 times x plus 4 is equals to x times 2x plus 7. Minus 3x minus 12 is equals to 2x squared plus 7x. Then I will move the 2x squared plus 7x, this one to the right hand side, plus 3x. Negative become positive is equals to 0. 2x squared plus 7x plus 3x plus 10x plus 12 is equals to 0. And I will divide the whole equation with 2. X squared plus 5x plus 6 is equals to 0. Just then I will do factorization. 3, 2 plus plus. So x is equals to -2, x is equals to -3. Okay? Actually, you can find the answer directly from the calculator. I could share this video at my YouTube channel. You can have a look, okay? Example, I will teach you how to draw a graph, okay? Sketch the graph for each of the following quadratic function. F(x) equals to x squared minus 3x minus 10. There are only 3 steps. You just follow these 3 steps, okay? The first step is determine whether your a is greater than 0 or a is smaller than 0. When a is greater than 0, your graph will be a smiling graph. When a is smaller than 0, it will be a step-based graph, okay? For the second part, you have to find the roots by using the factorization. And then the third part, you have to find the y-intercept. So that's 3 steps, okay? So let us look at the part A. F(x) equals to x squared minus 3x minus 10. My a is equals to 1, so it is greater than 0. I know that my graph will be a smiling graph. And for the second step, I have to determine the roots. X squared minus 3x minus 10 is equals to 0. Then I will factorize it. 5, 2, minus, plus. Then I will get x equals to -2, x is equals to 5. The roots tell me my graph will be look like this. Okay, smiling graph, and it cut the x-axis. Here is -2, here is 5. Okay, so the last part, the y-intercept. The y-intercept, this is the first, second, and the last. When x is equals to 0, what is my y value? Okay, my x is equals to 0, my fx is equals to 0 square minus 10, so it's equals to -10. So I know that it cut the y-axis at -10. So this will be my graph. And don't forget, everyone have name, it also have name. X squared minus 3x minus 10. And you also can plot the minimum point. -2 and 5. The distance between -2 and 5 is 7 units. So I know my minimum point here is 3/2. Now I have to find my y value. So my fx is equals to 3/2 squared minus 3 times 3/2 minus 10. I will get my answer as -12 1/4. So here is -12 1/4. This is my minimum point. Okay, my axis of symmetry is x equals to 3/2. This is my axis of symmetry if the question got asked you. Okay, so let's see the part B. My A is -4. So it is smaller than 0. So it is a set face. Okay, so for part B, -4x squared plus 12x -9 is equals to 0. Now I have to solve it. I will get my answer as 2x minus 3 negative 2x plus 3. X is equals to 3/2. X equals to 3/2. You see, the answer is the same. That means I only got one root. So my graph will be look like this. Okay, only cut the x-axis at one point, which is 3/2. Okay, so I have to find my y-intercept. So my fx is equals to, when my x is equals to 0, my fx is equals to -9. So this is -9. Here is x, here is y, and the name of the graph is this. Okay, and then how about my minimum point? My minimum point is 3/2, 0. This is my, not minimum point, is maximum point. And how about my axis of symmetry? My axis of symmetry is x equals to 3/2. Okay. Example 9. The diagram below shows a composite shape of a square QRST and a triangle PQT. If the area of the trapezium PQRST is 100 cm square, find the value of x. So this is a square. That means all the sides is the same size. Okay, here is also the x. From here, I can know that x squared plus 1/2, 9 times x is equals to 100. Now I can times the equation with 2. Plus 9x is equals to 200. Now I can make my equation become -100 is equals to 0. Now I can solve my quadratic equation. Okay, become 2x plus 25, x minus x. X is equals to -25/2. X is equals to 8. Since the length cannot be negative, so this will be rejected. My final answer, x is equals to 8 cm. Okay? Example 10. Umail is cycling for 36 km at a uniform speed. If he cycles 3 km per hour faster than his usual speed, he will arrive at the destination 1 hour earlier. Find his cycling speed in km per hour. Okay, so the velocity is distance over time. Okay, so let x equals to the original speed. To find the time taken, we have to use the distance over velocity. Okay, what is the original time taken before he speed up his speed? Okay, the original time taken is the 36 km over his original velocity, okay, which is x. After he cycle faster, that means 36 over x plus 3. The velocity is speed up, is faster, plus 3. So the speed is x plus 3, but the distance still the same. And he reached the destination 1 hour earlier. In another way, we can say like that. If I go to school, normally I use 3 hours to go to school. If I speed up my speed, I use 2 hours. Then the difference is 1 hour. I reach school earlier 1 hour. Can you understand? Okay. So now I want to solve this equation. Then I will make the denominator become the same. This equals to 1. Then I will get my equation as x squared plus 3x minus 108 equals to 0. And I will do the factorization. I will get x minus 9, x plus 12. X is equals to 9, x is equals to negative 12. Since the velocity, the speed cannot be negative, so my original speed is 9. Okay? That's all for this video. Do remember, like, share, and subscribe my YouTube channel. Bye!